related disciplines in bioinformatics at Georgetown University Medical Center. And he has so far received numerous awards and honors. Among them, he's a fellow of ACM, IEEE, and AAAS. For information system students who may not be familiar with the AAAS, it means American Association for the Advancement of Science. One of the leading journal is Science, which has impact factor of 30 and above, so you can know its impact. And Dr. Zhang received the fellowship for recognition of his achievement in scalable information systems, ranging from communication system to information processing, search in distributed data, and multi-type data information systems. And today his talk will be on collective intelligence. So I just searched the word intelligence from the online dictionary. It means that the ability to understand and learn new things and also deal with new and difficult situations. So I believe that we as human beings have intelligence, particularly PhD students and master students who are dealing with new and difficult situations on a daily basis, right? And however, that for many pretty specific tasks, there are only a small pool of people who may have the expertise or who are qualified. So, and they are not easily accessible. And if we trace back to the long history of artificial intelligence, people have tried to empower computers with intelligence. And however, it has come to our realization that a computer, no matter how powerful it is, may not be able to handle the complexity of human language, not to mention our common sense, our perception, environment, context, and our creativity. So in recent years, and the intelligence of the public at large have tapped into to address some business-related and research-related tasks and problems. And in this kind of platform, probably there's no clear distinction between producer and consumers. So we have heard a lot of research on how to motivate users to participate in this kind of platform, but much less on how to actually leverage the power of user-generated content on this kind of platform. And Dr. Frieder's talk will touch on this issue. Without further ado, let's welcome the speaker.
Thank you for that overly generous introduction. The cardinal rule of any place that anyone lectures is that the front row and the next row will always be vacant. And for somehow, everybody will manage to find a way of cramming to the back. But my voice carries, so in this case, even in the back, you can't really sleep very well because it's got too loud of a voice. Title of my talk, and this is the first time I'm giving it, title of my talk is on collective intelligence. Now, you'd say, what is collective intelligence and why did I name that talk? Well, a little while ago, before I was asked to submit a title, or before I was even invited, I heard a talk, and the talk said that if you ever have to give a talk, you should name it something like The Line in the Path. Why the line in the path? The line in the path is, well, sounds ominous, right? It's a lion, it's a big thing, it's important, it's powerful. And it's in the path, so it's in your way. But it actually covers anything under the sun. So it basically binds you to absolutely nothing. You can talk about anything you want, and it still fits within your title. So when I was asked to give a title for a talk, I said, all right, we'll pick collective intelligence. What was I going to talk about? That was a good question. I'd figure it out by the time I actually had to do it. And I wrote an abstract that kind of allowed me to have a little freedom. So this talk is what you'll make out of it. And any comments are greatly welcome. All right, so the first thing is, what is collective intelligence? Well, so you look up in Wikipedia, which is a big source of collective intelligence, and you get a definition that says something that a group uses that comes up and solves together. And they say it's a great new direction in computer science. Well, first of all, it's not new. It's not at all new. Nature's doing it all its lives. Packs of wolves hunt together, birds migrate together, ants build things together. And so nature's had collective intelligence for a very, very long time. So nature knew it all along. Well, okay, well they said it's computer science. Well, it's not even new in computer science. In fact, it's not even new on the web. What is collective intelligence? Well, how many of you have taken courses in information retrieval? At least heard of information retrieval. All right, good enough. If you go and take the first course in information retrieval, the first thing they'll tell you is the way we used to solve all these problems was really easy. We put together a string of ands, ors, nots, and whys, and basically see which words appear in a document. Apple and orange, but not pear. Now, I don't know how many of you have actually gone to a library. People my age used to go to libraries all the time. And when I was young, we went to libraries to get books. I came a little older, we went to libraries to drink coffee. Nowadays, they don't even have libraries to drink coffee anymore. They just call them Starbucks. And that's not such a good place, but it's okay. How many of you had Pete's coffee? Much better. Anyway, going back to the topic, the fact of the matter is in information retrieval, the first thing was Boolean retrieval. It's ands, ors, and nots. But people realized that when you have large amount of data, you couldn't do that. So you had to rank them, right? So it wasn't good enough to tell me all that fit. You had to give me a rank order of that. And that's not new either. But when they built the search engine on the web, they said we're going to do things with our relevance ranking. We're going to do the same thing. We're going to rank what is relevant. And the way we're going to do that is we're going to look for the content of the document or the web page. And basically, if it was relevant, i.e. high enough ranked, we would return it. Quickly, they realized that's a waste, because that didn't utilize the most important power of the web. And the most important power of the web is you. It's the fact that billions of people, billions of clicks on a daily basis are telling you what is good and what is bad. I assume you've heard of a company called Google. Google makes $40 billion roughly a year. At least that's what the statement there was in their advertising. And they make that predominantly on advertising. And how do they make advertising? They actually, when you do a search on Google, it actually comes out that the ads, which are usually up top or on the side, are actually very accurate. They are not just blindly doing it, and the way they're doing it is they're defining the words based on quote-unquote you, the collective intelligence. The people who are voting with their clicks on what is relevant and what is not. Now, what do I mean by that? Macintosh. What is Macintosh? Well, all of you know that it's a successful computer line by Apple. I'm, by the way, using one of the few people that are not using the Mac right now. I'm using an old historic computer just for the namesake of it. So most people would say when they say Macintosh, will think of the laptop, computer company. Some will actually think of fruit, believe it or not. But even more few, how many of you have heard of the Macintosh clothing line? There's always one. Actually, there's two here. Actually, I didn't. I was only going to use, I basically was only going to use the fruit and the company. So I Googled it, and lo and behold, I see down there, there's actually a wow, okay. So, but if you're going to bias towards something, you're going to bias it towards the computer company. And the reason being is, these are not real numbers, but the reason being is, illustratively, 60% of the time, people are looking for, in this case, the computer product. So the collective intelligence has always been there. We've always used it, and in fact, now we're using it for almost everything. All science is being used collectively. Information source is the Wikipedia. By the way, how many of you have heard of Britannica? Okay, when I was growing up, when I was a kid, I was given a gift. Oh, big volume. Encyclopedia Britannica in print. It was a very, very expensive gift. How many of you have even seen that? Okay, as I get older and older, fewer and fewer. Now, Britannica doesn't even exist in print. You can get it online, and even that's not doing very well. Nobody uses it. Why? Because the collective intelligence knows better, and they use Wikipedia. Wikipedia is a group-oriented social media, not social media, but group-oriented encyclopedia that everybody's making sure that it's actually correct. I use it all the time. And what's sad but true is that the most popular news source today is Twitter. And in fact, you can't get around it. You go and look at the news sources on TV, and where they say, well, this is coming from Twitter, right? How all you remember all the Arab Spring information or the Iran student uprising? Where'd you get the information? Where'd they get the Twitter? So, but I'll comment on that in a little bit. So, what's today's talk? Well, today's talk, I'm going to try to do it slightly different and show you how the collective intelligence can actually help and do things in a positive way in some sense. And the first thing I'm going to try to do is I'm going to try to change the word surveillance and put a positive light on it. You mentioned the word surveillance. By the way, I think we're pretty close to the popular TV site of surveillance. There's actually a good reason for surveillance, and I'll try to give you a positive spin on surveillance. And the way I'm going to try to do that, I'm going to talk about detecting outbreaks in their infancy. And you'll see what I mean in a second. Then I'll go on and I'll talk about vocabulary, vocabulary, vocabulary. How do you choose when it's a good house? It's all about location, location, location. The three most important things about a house. And everything you do in search, everything you do in integrating material is all about vocabulary. So I'm going to talk about vocabulary, vocabulary, vocabulary. And what I'm going to show you is that using this proper constructed vocabulary, we can detect adverse drug reactions. So as you can see, the bias of these first two are strictly in the medical school, and you might guess that the 800-pound gorilla of Georgetown is no comment. Anyway, so these are what I'm going to spend almost all the time on. I'm going to quickly, and yes, it's shaded intentionally, I'll quickly speed through another example, and it's this came out just too shaded. I'm going to talk about a little bit of a tagging systems, and I'll talk about a little bit of work in collective intelligence for tagging. And I'll actually show you that there's actually some more, and it's not even to do with the web, of integrated information. And I'll talk about organized answers. So let me try to move it to content. So surveillance in a positive light, and I'm going to talk about detecting outbreaks. How many faculty here? Okay, you all agree, and if you don't agree, the students certainly will agree. You know what the faculty do very well? They do very well presenting their students' work. So none of this work would be without the students. And in this case also with a faculty member in the department. So Nazli Goharin's in the department, and Andrew and John, students. And this is actually joint work with the Johns Hopkins University, the emergency medicine department. So how do you deal with, how is public health surveillance done? Well, patient goes to a doctor, kind of feels sick, has some symptoms, doctor notes it, says go home. Next patient walks in, the doctor has the same symptoms, doctor notes it, goes home. Third patient comes in, same symptoms, doctor notes it. After a while, the doctor says, wait a minute, I'm sending a trend. So they notify the Department of Health and Human Services or the CDC, or take your favorite indication. And it turns out that a whole bunch of these doctors do the same thing, and after a while, they say, wait a minute, there's an outbreak. That's how it's done. There's a problem with that. First of all, it takes a huge amount of human effort. It takes not only human effort of the doctors, but it takes human effort of the patients who actually went to the doctor. By the way, when was the last time you went to the doctor because you felt sick? I don't go usually. I think I'll take a few aspirins and eventually I'll be okay. Right? So it takes even longer because a lot of people put it off. It takes time because it has to take a while to occur. So that's a real problem. And therefore, and more often, usually the doctor has to think of what is the topic that caused this thing. So it takes identification. And that's a serious problem to maintain. So you ideally like to do it quick, and you'd like to detect it without having to know that you're looking for flu. And therefore, the motivated expedition of a detection is what basically motivates people to look at social media. Everyone says you can find everything on social media, and we'll address what that means in a second. So, social media. Are we the first to deal with it? No. A lot of people have dealt with the detecting of information on social media for health. The problem is, and what most people have done, doesn't mean it's a problem, my view of it is a problem, is that they were looking for something. They were looking to find, is there a flu outbreak? Is there a dengue outbreak? Is there a malaria outbreak? Is there something that's an outbreak? And they were searching for it. The problem is, if you already are searching for something, what it really means is you actually think that there's actually something there. In fact, you believe it's a flu outbreak, and you're trying to see if it's out there. So the things that you aren't expecting, you just don't know, and you won't find. So that's not good. That's a problem. Other people have tried to be very elaborate. How many have heard of the KISS principle?
Keep it simple, stupid.
Keep it simple, stupid. The bottom line is that I can't think of things that are complicated. I'm not bright enough. And if you can't understand what you're doing into great detailed way, if you cannot give an elevator pitch, you know what an elevator pitch is? An elevator pitch is about 20 seconds on an elevator, and you have to convince somebody that what you're doing is useful. If you cannot understand in one sentence or two sentences what you're doing, it's never going to see the light of day. So that's what other problems have. And finally, there's others that worked in a slightly different way. They used query logs. If you're at Microsoft does a lot of very good work on analyzing health using their query log. Do you have their query log? Can you get their query log? You think they're going to give you their query log? How many of you heard of the AOL query log release? I know it very well. It was my student that did it. So you're not going to get the query logs, trust me. So our goal was different. Our goal said we don't want to know the topic. I mean, we don't want to know ahead of time. We want to see if there's something out there. We want to be able to use information that can be done quickly. And we want to be able to do it in such a way that we don't, quote unquote, prove anything. Why? Because I know it might surprise you, but sometimes people lie on social media. And you'll see what I mean a little later. So the old way was, we're going to take pre-existing conditions, or conditions that we know of, and we're going to find out if social media backs it. So we're going to say, is flu occurring more frequently? And the answer is yes. That's what people have done. That's not what we want to do. Our goal says, we want to generate hypotheses, and these hypotheses you should verify other ways. You should not be looking to, quote unquote, validate via social media. You should be looking to get a set of hypotheses that may be able to suggest that certain things occur in social media. So, are there any illnesses occurring more frequently? If so, which ones? And the answer is yes, they are, and it's actually to be the flu. So our goal is to generate hypotheses and give you an indication that you should be checking it elsewhere. So, let me show you how we did it. We started with a tweet corpus. In this case, we started by asking our colleagues at Johns Hopkins University to provide us a 2 billion tweet collection. It's about from May 2009 to October 2010. But all those tweets are obviously not related to medicine. They ran it through a big filter. Their filter had a bunch of vocabulary that they health related. They had some learning mechanism. They filtered it out. We came down to approximately 1.6 million tweets. So about 0.1% survived the filter. So what did we do with this? So here we start with our medical tweets. We then partition the tweets by time, right? We're going to try to detect if there's something occurring. Is there a spike in number of people with flu? So we partition it by time. So there's T1 through Tn. We found words that are common, they're frequent. Then we do a time series detection on them. We run them through a filter of Wikipedia. We use Wikipedia to gauge an indication of it's medical or not, of condition. And then we tell you it trended. That's the high view. Let me actually tell you what we did without skipping slides. So we start with this tweet collection. And this time we use a tweet collection where the bird's actually flying. How many of you used Twitter early on? Very early on. When you looked at it very early on, they had a picture of a whale. And it said, "Gone fishing." You know what that was? Wasn't working very well then back then. But anyway, we used the bird because it's actually succeeding. We did 2 billion tweets. We had it filtered. We got 1.6 million tweets roughly, health related. And we partitioned it at time. We did it by month. Now the obvious question is, why by month? And I'll give you the honest answer. We only had 1.6 million related tweets. Why? Because we had a very small collection. If you have a real stream of a tweets, when you run it through the filter, 2 billion tweets is nothing. How many tweets do you think they are generated roughly a day? Well, numbers that are tossed around are about 400 million. Right, so 2 billion isn't exactly your nice number. Right, so if we assume that we would get 0.1% as a number, then we could do it much better today with not months. But we didn't have it, so we did it by months. So in May, June, July, so on and so forth, we partitioned by our tweets. We cleaned them up. What do we mean by clean it up? We got rid of punctuation mark. We lowercased everything. We got rid of stop words somewhat, not always, depending on how we ran it. We noted the duplicates, but we didn't eliminate them. And we expanded them by using a medical dictionary, which we actually created. It's called Medicine. It's a synonym list for medical terms. Why? Why do we need that? Without that, we'd be in trouble. Why did we need that? Well, it's a very simple question. How many of you tweet? How many of you actually have seen tweets that said renal cell carcinoma? No. Blastoma? No. Neoplasm? No.
I've seen adenocarcinoma. I think that's right.
Right. Surprising. How many of you actually saw the word cancer?
Yeah.
Yeah. Those where I was rattling off our type of cancer. Renal cell carcinoma is kidney cancer. All right, so we needed to be able to use the vocabulary that people are using and mapping it on so we can detect a condition that's occurring. So we use the medical dictionary. So here's an example of 5 hypothetical tweets. They're not really the tweets. And you see pounding headache, sore throat, and low-grade fever and flu. Sleep, a perfect cure to forget about pain, and so on and so forth. This morning woke up with fever and sore throat. And what we do is we take those tweets and we basically mine them or associate them and generate a frequent term set. So in this case we have flu, sore throat, which it has a support of 3, i.e. it happens in 3 of the tweets. Fever happens in 3 of the tweets. Cough happens in 2 of the tweets. And we only care about the ones that happen at least in 3. So in this case we have a frequent term set that is flu and sore throat and fever. Now we want to know, does this trend? Now how many of you have got a math background? Okay. How many of you have taken high school math? Good enough. You know, if you want to make something sound very more impressive, you use the right vocabulary. So what we did was we did a trending technique to see if it trends and spikes, and I'll show you what I mean in a second. And what that says is we had to be a frequent word set, and we wanted to see that it was more prevalent now than it was last time. But the way to phrase that is, if you graph it, what am I looking for? Slope. Slope doesn't sound very good. You can't publish the word slope. That's like low, that's elementary school math. You do derivative-based. You do derivative-based, so you know what a derivative is? So we did derivative-based trending, and here's an example of what we did. So what you're seeing here is a time series of words, of a frequent word sets. And what you see here is we have to make a trending decision. So if you look at the blue line, this is for feel sick. This happens to be very frequent, but it doesn't trend. Even though it's occurring very often, there's really no great slope difference at any point along the way. On the other hand, if you look at allergies and feel, it does trend in April and May. As you can see, it spikes. So in this case, we would say allergies and feel is trending. Now we take those that are trending and we run them through a filter. And we use collective intelligence. So far we're taking all the information from all the people, right, the tweets. We run it through a filtering mechanism which you call Wikipedia. And what happens if you query with Wikipedia? How many of you use Wikipedia? Think, what happens when you give a query to Wikipedia? Gives you a set of documents. Take those documents, and what do those documents tell you? About what you've got. So if we basically have taken the words from the vocabulary we trended, that happened to be spiking, and we said, what is this telling you? We look at Wikipedia. Wikipedia is helpful because it's written in the same language as the tweets, but also has vocabulary that is actually medical. And it's comprehensive. So if we took those documents that we retrieved from Wikipedia, and we look at the ratio of the words that are medically related in the introduction and the abstract, or we look at the ICD code classification that is marked in the document. You're looking at me, what is he talking about? How many of you have ever gone to a doctor? Ever? How many of you actually have health insurance? I know that's not a popular question nowadays.
Does it give ICD-10 codes?
Wikipedia gives ICD-9 and ICD-10 codes. ICD is the billing code the doctors use to, quote-unquote, finagle a payment from the insurance company. And if the doctor's creative, they'll be better at coding. And if they're not, you'll get denied for a lot of stuff. But anyway, Wikipedia has ICD codes. This is an example of how we did it with medical tokens, and I told you by percentage of the introductory word. But the more popular way, the easier way of doing it is this is an entry for sore throat. I apologize for being so small. That's I'm the guinea pig for the videotaping. You're the guinea pig for this presentation. So I guess I'll make it bigger. But as you can see in red are ICD codes. Therefore, this is a medical condition. And it's billed by those two codes. And therefore, you know it is a medical condition. So, that's the way we detect if it's a medical condition. Now, let me tell you if it's any good. So, I don't know. No one can tell you if it's any good, but I can give you some hints of why it might be okay. What you're seeing on, when you're seeing on my right is what we spiked on flu. As you can see, we spiked twice. Once we spiked a little, that's in over here. It's July of of 09, and we spiked again much more a few months later. What you're seeing next to it is what actually happened according to the CDC. So as you can see, you don't worry about the labeling, but what you're looking for is a spike in the shape of the curve. And as you can tell, we did detect when a flu epidemic is going on. We also detected it falsely. We had a false positive. Not as severe, but we had a false positive. That's because we don't try to prove anything. We are actually trying to give you an indication of what might actually occur. And therefore, you should verify it from legitimate sources. There are ways of trying to filter out those conditions because we're looking to see what is commonality, what spiked it. But the point of the matter is we're not actually trying to prove anything. We're trying to guide you. And why are we not trying to prove anything? Well, social media is a great source. It gives you a lot of information instantaneously, and often it is correct. Social media was the first place, Twitter was the first place that talked about a Scully landing on the Hudson. So Twitter was the first that had talked about the Mumbai terror attack. And it was completely accurate at that point. It also is about 95% accurate at detecting flu tweets. flu conditions, and people have done that. So you can feel kind of comfortable about detecting using social media, but let me go ahead and give you other examples. Hurricane Sandy relief efforts, a lot of it was coordinated via Twitter. Sometimes it worked, sometimes you went to a location that didn't quite exist. In fact, sometimes you went to a location that was actually in the ocean. I guess you didn't quite tweet correctly then. But that still had partial correctness. But the best story about Twitter and why you should never count on it as a pure source, even though it's right a lot of them at a time, is the story of Jeff Goldblum. Anybody know who Jeff Goldblum is? He's an actor. This became very popular in 2000, very famous in 2009. How many of you have seen the Colbert Report? It's my favorite show. If you haven't seen it, you should. It's very humorous. Anyway, the Colbert, Jeff Goldblum, when Michael Jackson died, on Twitter it was announced, and he died. Also on Twitter was announced the death of Jeff Goldblum, a movie star, who, by the way, is in a movie recently, so he probably didn't die in 2009. And this is coming from probably with a person with a medical position. I'm not a medical doctor, but I can figure that much out. What happened, it was such a big news item that he quote-unquote died, and Twitter declared him dead, that Stephen Colbert brought him onto the Colbert Report and was talking to him from the grave. So Stephen Colbert was talking to Jeff Goldblum from the grave. And the bottom line, it said, well, Jeff Goldblum said, I'm not dead, I'm not dead. You must be dead, because Twitter declared you as such. Needless to say, you can't bank on it being correct. But you can have an indication of what people are talking about, and if they're talking about something, there's some cause to it, be it right or wrong, and you should investigate it. If you look at another example of sinus condition, it peaked around the March-April time frame, the biggest peak. And you'd say, why would you be looking at sinus conditions at that time? Why would people be talking about it? Well, how many of you suffer from hay fever? Allergies. You probably can know very well what happens around that period. But actually there's other allergies too. Here's an example of what else spiked exactly the same time, or kind of exactly the same time. There's also food allergies for certain things that occur at that time. These are all based on what spiked. Now, am I telling you that that's the cause? No. But if you want to detect certain conditions, there's a condition for it. Our system is actually, I just gave you a simple example. It's just our system is held together by chewing gum, paper clips, and a couple other rubber bands and a piece of masking tape. But it's actually very modular. It basically informs into 4 parts. It does initial filtering, in our case, health filtering. It does time slicing, in our case, a month. It does an is trending algorithm, which I, of course, did not call sloping. I call derivative based. And it uses frequent word set concept to filter. In our case, we used Wikipedia. Very modular. We're deploying it to a variety of different things. Is this complete? Not even close. Why? Because everything I told you is very much fresh off the burner. We published it in August of this year. We used only 2 billion tweets instead of 200 billion tweets. We did it on months versus weeks versus days. We use Wikipedia ICD codes, which why that? You can do something else. We detected only various things related to medical, and why should we do that when we can detect many other things? And we were going to stop until somebody from Twitter, who was involved in Twitter Health, contacted us. And he said, you know, let's see if it really works. So we're now in discussion. It's not finalized. We're in discussion of trying to run it really on Twitter, in which case it cannot be held together by chewing gum and the like. So I am sure that what we developed may be there in concept, but not at all in software. So if you take anything away from this, is that social media can help. Its truthfulness is suspect, but it does give an indication of what's going on, and therefore you can generate hypotheses you can validate in other ways. And of course, we're academics, so we needed to publish something. All right, that tells you about Twitter, and that tells you about detecting what people are talking about or collectively spying on what's going on in the world. But the reality is that it's only good as much as you can actually understand what's going on, and it's only good if it actually maps onto vocabulary that actually intensifies what you're looking for. So in order to enhance what we did, we worked on building a significant enough vocabulary to be able to detect conditions which are not as like flu, but actually are more medically oriented in specifics, which are adverse drug reactions. How many of you know how the FDA releases a drug? Well, it goes through stages. First, there's stage, what's called phase 0. People don't usually talk about it, but that's first you do it with test tubes, and then you do it with animals, and then at the end, when you're just about to touch this with a human being, what you do is you do it with phase 0. It's a small percentage of the dosage of what you're going to be actually having to take to treat the disease. Is it toxic that you didn't know about? If that survives, it goes to phase 1, which is a small number of people, test subjects, guinea pigs, graduate students. People snicker. Okay, never mind. Gets a little bigger population for phase 1, and for phase 2, they may be undergrads. And eventually, if it works well, you go to phase 3, and if phase 3 succeeds, then it's released to the market. It usually tests on about 1,000 patients. What's the problem with 1,000 to 2,000 patients? How representative is that of the population? Well, the average patient typically, there may be, I don't know if there's any average patient here. There may be 1 or 2 average. Average patient is typically male, typically in the range of about 35 to 40. Typically of European descent. That's the average patient. That kind of knocks out the vast majority of the people that basically are not the average patient. In this case, almost everyone. So what we're trying, so what happens after the fact, we do post-marketing surveillance, which is pharmacovigilance, which is the monitoring of what is out there that's occurring in the mass-marketed drugs. That's also how you get the big class lawsuits for the effects they didn't detect. This work is a collaboration with actually 2 faculty members and a student. Howard Federoff's the head of the medical center, Nasli the faculty in my department, and Andrew, their student. So we want to detect adverse drug reactions. And adverse drug reactions, we're going to try to see what are people talking about on blogs, on forums, on Twitter. And what really we want to care about is one of 2 types. There are 2 types of adverse drug reactions. One's the expected, one's the unexpected. The expected is when you buy a drug, it tells you this drug can have the following side effects. So they're usually written by lawyers. If you actually listen to exactly what are those adverse drug reactions on the label, you'll never take the drug. Because almost every one of them has a minor side effect called death. They go overboard, and you'll see what I mean in a second. So what you really care mostly about is the unexpected, the ones you don't know about. So really, so what are people doing? So very, very few have studied the ADR problem, the adverse drug reaction problem in social media. And those that have typically ignored what I think is one of the key issues, which is the language. And language has got 2 parts. It's got structure, so we developed some parsing techniques to cope with it. And it's got vocabulary, which means we developed a thesaurus to cope with it. You'll see what I mean. So here's a post. Here's an arbitrary post. And what this post describes are 2 adverse drug reactions, namely restless legs and achy legs. But nowhere in this post does it say restless legs or achy legs. It clearly means it just doesn't say it. So we developed a parsing technique to deal with these kind of situations. But before I spend a lot of time on the parsing technique, or the detection mechanism, let me talk to you about the building the thesaurus. Well, the problem is that vocab posts don't use medical thesauri, and medical thesauri don't use common language. So you needed to build a bridge, a thesaurus, per se, between what people say and what doctors say. Or what doctors say and what people say. And the way you do this is basically developed a logistic regression system that really had 8 to 12 features on it, but really they can partition on 3 things. Synonyms should be used the same way. They should be used with similar terms. And they should be able to be used within the same size or same sentences often. Whether you agree or you don't agree, it doesn't matter. Those are how we categorize them. And compared to the others, we did okay. Right? All academics show you charts. Right? So we did okay. You can guess which one we are. You can guess which one you are because if you wouldn't have guessed blue, I wouldn't have shown it to it. Right? Nobody gets up here and says, oh, by the way, we did this great work. We're the ones way in the bottom. No, in this case, blue is good. So we take the thesaurus, and we take the social media, and we grind them together, and we decide, what can we detect? So the first method was not ours. The first method was started a few years back, and this is basically a sliding window. Simply said, you take a contiguous set of words, anything within that window of words you alphabetize, and you do all the combinations. And sure enough, if you look at the posts, that section would generate you achy and R legs and restlessness because they were alphabetized. And sure enough, what you find there is achy legs and restless legs. We started with that and said, oh, wait a minute, we can improve that. We can take the same type of notion, we'll take exact matches of patterns, or we will take patterns. So if you actually have restless legs, that's good. Or you could have a pattern that can derive you that. For example, legs are achy and restless. And if we learn the pattern that says area R, X, and Y, it spits out achy legs and restless legs. So far, so good. And again, that was before my time. How many of you have taken a course in IR? How many of you have ever been to anything in information retrieval forums? How many of you ever have to take an exam on information retrieval? Okay. Today, every exam will say the end-all, first all and end-all solution is topic models. See, I'm in IR, so my solution had to say I'm going to use topic models. Actually, I never believed in topic models very much, but had to do it anyway, because it's the way to do it, so we tried it with topic models. And topic models really is a learned set of vocabulary that are how would people talk about a condition. So here's an example. So here's one ADR, which is carpal tunnel syndrome. And this is a learned vocabulary of what would be describing as carpal tunnel syndrome. The problem is, you can see here, is the red ones are pretty good, carpal tunnel syndrome, and this is by frequency. So the red ones are pretty good. The bolded ones are okay, right? So you can say that, yes, you can wear something for a brand, for a company, it can trigger an event, and it is a diagnosis, the DX. But the light standard writing isn't exactly very helpful. Resolve, multiple thought, bathroom. So the topic model learns automatically, but to within some level. Let's try hair loss. That one's even worse. Hair, the number one is I. Back, give, surgery, am, long, not so good. But it did learn hair loss, and it did learn thinning and chemo. And tamoxifen is a breast cancer drug that if you take it, you'll have hair loss. And thyroid problems are conditions, and they cause hair loss. So you learned something. So it's the third method. And the fourth method, the other thing you try, is conditional random fields. Okay, yeah?
So the topic models created from the tweets or?
I'll get to that in a second. So the other one is conditional random field. It's the fourth approach, which is basically a probabilistic based approach that labels a term based on the term's features and the previous term's label. You'll see what I mean in a second. But you need to learn this. You need to train this. So what we did was we needed to get a bunch of annotations to be able to train the posts, understanding. So here's the labeling we use. It's inside an entity, outside an entity, begin an entity, end an entity, single word entity because we only have one label, and it's either part or not part of an IDR. Very confusing. Maybe this will make it easier. So if you have the post, interesting that you mentioned achy legs. The first 4 words are not part of an ADR. Right? So it says part, no. And in fact, it's not even labeled. The aching legs is the beginning of an ADR, because aching, and legs is the end of an ADR. And indeed, they are part of an ADR. So we label it as part and beginning and end. If you take my legs are achy and restless at bedtime, then mine is nothing. Legs starts the ADR and it is part of it. R is inside the ADR and it's nothing. So on and so forth. And restless is the end of the ADR and is part. And what can you do from that? You can run the stream and it will label to you and give you information about the parts. So how do these work? That's the most important issue. Well, the evaluation is, we took breast cancer forum. We took 400,000 posts from a breastcancer.org and FORCE, which are facing our risk. And we wanted to evaluate them. There's only one problem. You need to, quote, annotate them. And you need training data. And we are not a big state school. So we're like University of Texas. It'd be easy. Go tell all the undergraduates to go label and we can do anything we want. We're a small school. And in a small school, we don't have all those volunteers. So we took 600 posts, and we had 2,100 human annotations by having a group of people annotate. And we defined that as our annotation and our training data. That's one evaluation we did. I'm going to tell you another evaluation in a second which talks about ground truth evaluation, but we'll see what I mean in a second. So here's our evaluation on a cancer form. That answers your question about tweets. This is on the cancer forms. As you can tell, the conditional random field did better. And the reason it did better, this is an F1, it's a combination of recall and precision. The reason it did better is because it's very, very, very accurate. What it finds is very, very accurate. Its recall is not so good, but the precision is very accurate. Exact matching and sliding windows are okay. And the end-all solution of topic models didn't do so well. Didn't do so well, and the reason it didn't do so well is that, as I showed you with the vocabulary it found, it has a huge amount of diversity. And when you go to posts, those off words affected it significantly. So we were kind of happy, kind of get a result. And all of a sudden we realized, you know, we really didn't do anything. Because we used 600 posts. How can we do it on a whole collection? Even worse yet, how can you do it on something like Twitter? The problem is annotation takes a huge amount of human effort. So we said, let's take advantage of something else. Let's see if this approach works at all. And what we're going to do is we're going to take advantage of the drug labels themselves. So the drugs that I told you has got a whole lot of ADRs listed with them. We'll assume that those are indeed true. And we also know that they're ranked order by the likelihood of occurrence. So we're going to detect an ADR that matches the drug label. And we're going to use that to estimate precision. So here's what we did. And as you can see,